So first of all, what is related rate? Related rate are problems involve two or more variable change at the same times. If we know how they are connected and how fast one changing, we can find how fast the others is changing. So for the next slide is example. This usually involve writing an equation relating the two variables and taking the derivative of equation. So let's look at our example. Here we got a glass of water. The volume of water in a glass increased by the times the equation will be dV over dt. dV will be the changes of the volume and dt will related to the time that's changing. Application related rates. In physics, related rates can determine how fast the head of water rise in a tank and it is being filled. In construction, they help calculate how quickly the top of a ladder slide down a wall as it pace move. And then here we got problem statements. A conical water tank has a radius of 3 cm at the top and 50 cm height. Water flow into the tank at a rate of 6 cm over seconds. A. Show that the volume of the water is given by V equals to pi h power of 3 over 75. And for question B, how fast is the head changing at an instant when the height of the water is 5 cm.
Now we were given a conical water tank with the radius equals to 3 with height is equals to 15. Now it said that the water flows into the tank at a rate of 6 cm per second, which means volume over seconds is 6. Now that we have this, let's look at question 1. Show that the volume of the water given is V equals to pi h cube over 75. Now what do we have here? We have our radius and our height. Radius equals to 3, height equals to 15. Now, we've noticed that there is no radius in the equation given on the first question. That means we have to convert the r into h. R with respect to the h is equals to 3 with respect to the 15, which means h is equals to 5r. Now that we have that, let's continue with the volume of conical water tank. The volume of conical water tank is 1 over 3 pi r squared h. Like I've mentioned before, let's convert the r into h. R is equals to h over 5. 1 over 3 pi h over 5 squared h. Let's expand this. In the result, we will get h cube 75 pi. Now that is how we prove the first question.
Yeah. Okay, for the problem statement B, it is stated that it is asked that how fast is the height changing at an instant when the height of the water is 5 cm. Okay, so from the question, we already got that what the question wants. So what the question wants is dh over dt. So how do we get dh over dt? So first thing first, from what I see, the dh at the top and the dt is at the bottom. We got this from, we derive the formula. So what is this? What is this too? So from the problem statement, we know that the question is asking for the volume. So both of these places is dV. So what is the amount of these two? So first thing first, we need to know the dH over dV. So from the previous question, we already know the V. The V is equal to pi h cube over 75. So we differentiate that, we will got dV over dH. So the dV over dH is 3 pi h squared over 75. Cancel both of that, we got pi h squared over 25. So from this, we will inverse this question, this statement, to become dH over dV. So inverse that, we will get 25 over pi h square. So we already get dH over dV. Put that in the formula, we will get 25 over pi h square times dV over dt. From the question, from the statement, it is given that dV over dt is 6 cm. 6. How do I know dV over dt is 6? It is from the question that the flow tank at a rate of 6 cm. So in the term, it is dV over dt. So the question asks, the height of the water is 5 cm. So the height is h. We will convert the h to 5. 5 square times 6. After further calculation, we got that the answer is 6 over pi.
So the conclusion is the role of change water flow in the tank when the height of the water for 5 cm is 6 over pi. We can apply the chain rule or implicit differentiation when showing any problem that required to find rates of change related. So that's all from us. Bye!